Hi everyone. Basically my microphone didn't work at the start. Essentially what I'm saying is I'm going through mock set 1 paper 3 and also, like always, like and subscribe if you enjoy the videos, and I'll be posting a new one of these every 2 weeks, going through a new paper. Okay, so question 1. So buses to Ashby leave a bus station every 24 minutes. Buses to Barford leave the same bus station every 20 minutes. A bus to Ashby and a bus to Barford both leave the bus station at 7:30 AM. When will a bus to Ashby and a bus to Barford next leave the bus station at the same time? Now, this is a lowest common multiple question. So I need to find the lowest common multiple of 24 and 20. You can do that by listing your multiples and finding the smallest one in each list, or you can do it using a Venn diagram. Now, I'm going to do it using a Venn diagram, so I need to do the prime factor decomposition first of all, which is what I'm doing here. I'm circling my prime numbers and I'm splitting my number up into factor pairs essentially until I end up with all prime numbers at the end. When you get to all prime numbers, then you're finished, and so you can see 24 is going to end up as 2 cubed times by 3. Now I'll do the same with 20, 2 times 10, and then carry your 2 down, and 10 is 2 times 5. Make sure to circle your prime numbers. So 20 is 2 squared times 5. Then you need to do your Venn diagram. Now, in the centre of your Venn diagram is going to be the numbers that are in both, okay, the prime factors in our prime factor decomposition that are in both. So 2 2's in both. To make my 20, I need another 5. To make my 24, I need another 2 and a 3, so they have to go in just the 24 circle. Now your lowest common multiple is multiplying all of your numbers in your Venn diagram together. So 2 times 2 times 2 times 3 times 5. 5 times 3 is 15, times that by 2 is 30, times that by 2 is 60, times that by 2 is 120. Now that's in minutes, so 120 minutes is the next time both buses will leave at the same time. So that's 2 hours. 2 hours later than 7:30 is going to be 9:30 AM. So that's the answer. Question 2. Amzol thinks that x plus 5 in brackets squared is equal to x squared plus 25 for all values of x. Is Amzol right? So you must show how you get your answer. So first thing to do is expand the brackets, expand x plus 5 all squared. So that's going to give x squared plus 5x. Now I do this with eyebrows, a mouth and a nose. That's how I explain it. So 2 eyebrows at the top, the nose, and then the mouth at the bottom, squashed down in this case. Now essentially all you need to do is make sure you multiply everything in the first bracket by everything in the second bracket, and you can see me there explaining that I'm multiplying x by x to get x squared, and then x by 5 to get 5x. I then multiply everything by 5, so 5 times x, 5x, 5 times 5, 25. Collect your like terms, so x squared plus 10x in total plus 25. Now that's not equal to x squared plus 25. It's missing out the 10x in the middle. And so essentially Amzol's not right, because algebraically it's not the same thing. And so if we were to choose AX, it's not going to be the same. It's not going to give us the same answer. So no, Amzol's not correct. We don't need to write anything more because the maths is already there explaining it. Okay, question 3. Kim, Laura and Molly share £385. The ratio of the amount of money Kim gets to the amount of money Molly gets is 2 to 5. Kim gets £105 less than Molly gets. Now, the first thing you need to do is, or what I'm suggesting to do, or what I do, is do boxes or a bar method. So for the 2 parts, I'm going to do 2 boxes. Now that's for Kim, because Kim's name comes first in that sentence. So the 5 boxes is then for Molly. Now, it says that Kim gets £105 less than Molly gets, which means Molly must get £105 more than Kim. Okay, so that means the 3 extra boxes, the however many boxes, 3 in this case, is the extra money. So those 3 boxes is £105. So if 3 boxes are 105, then 1 box is going to be 105 divided by 3, which is going to give 35. Make sure to use your calculator. It's a calculator test. So that means in each box you're going to write 35. And then we can work out the totals for Kim and the totals for Molly. So the total for Kim is going to be £70. And the total for Molly, well, that's going to be 5 times 35, which if you pick up your calculator and type it in, you get £175. Now, the rest of that, Laura must get. So if we do 175 add 70, that's 245. So Kim and Molly have got £245. If you then do 385 take away 245, so the total take away what Kim and Molly get, that will tell you what Laura gets, and that is going to be £140. Now we're not quite finished, but it's always good in your working out just to be clear in what you've worked out. So good idea to write next to that £140 Laura gets, or this is Laura's money, something like that. Okay. Now we need to put that as a percentage. So to do that as a percentage, 140 out of 385, the total, multiplied by 100. Your calculator will change that fraction into a decimal to a percentage, times by 100. Okay, so type that in and your calculator will give you 36.36 reoccurring. The 36 goes on forever, 363636. Now we've got to round that to something, so 1 decimal place seems sensible, so 36.4. Okay, now I've resolved the hiccup and the microphone is working, so we'll carry on as normal. Question 4. Right, so table shows information about the height of 60 trees. Okay, frequency, height. Jacob drew this frequency polygon, okay. For the information in the table, the frequency polygon is not correct. So write down 2 things that are wrong with the frequency polygon. Okay, now usually with these types of questions, frequency polygons, well, these points, the frequency, should be plotted at the midpoints, okay, which is not the case here. I'm going to write down that he has not plotted the frequency at the midpoint of the height of the heights. Now the other mistake that Jacob has made is that with a frequency polygon, your points need to be joined with straight lines, not a freehand curve, as Jacob's done here. The points or crosses should be joined with straight lines. Okay, so it's just those 2 mistakes. Frequency polygon is plotted at the midpoint, so it should be at 2, 13, 6, 24, 10, 15, 14, 6 and 18, 2, which is not the case. He has instead plotted it at the end. The reason it's in the middle is because that's our best estimate as to the heights, essentially. We can't assume that all the heights are going to be at one end or the other end. Okay, Jacob's assumed that they're all going to be at the upper limit. Okay, question 5. The price of all rail tickets increased by 5%. The price of a rail ticket from London to Ipswich increased by £2.30. So it's increased by 5%. Now that 5%, the increase can also be represented by £2.30. Okay, now just by equating these two, 5% and £2.30, work out the price of the ticket before the increase. Well, if that 5% is £2.30, then all we need to do is work out 100%. So we can divide by 5 on both sides. So that'll give me 1% is equal to £2.30 divided by 5 is 46p, or £0.46. Times that then by 100 to get 100%. Times this by 100 also. So just times by 100. Answer times 100 gives £46. Okay, so that's our answer there. Now, next question, question 6. A, B, C, D, E is a regular pentagon. Regular part is important. BCF and EDF are straight lines. BCF, EDF, straight lines. Work out the size of angle CFD. So CFD are working out this angle here. Okay. Now, different ways to do this. You can work out the interior angle, or you can work out the exterior angle. So the sum of the exterior angles is always 360, and because this is a 5-sided shape, it's going to have 5 exterior angles. So if we do 360 divided by 5, that will give us 1 exterior angle, 72. That then means, well, this is an exterior angle. If you extend one of your sides, that angle it makes for the outside is the exterior angle. So that's going to be 72. Likewise, if we extend this side, this is also an exterior angle of the pentagon. So that's also 72. Now from there, CDF is a triangle. I'm just going to write here what I've done. So exterior angle of pentagon, triangle CDF is isosceles. Isosceles. I'll just double check that in a second. Isosceles. Always struggle with that spelling. Too many, well, S's, C's, which way around do they go? It is a bit confusing. Isosceles. Right. Angles in a triangle add up to 180. degrees. So 180 subtract 72. Subtract 72. Gives us 36. So this angle here must be 36 degrees. Okay, just double check my spelling of isosceles. I've got the S, right, I'll correct myself. So it is ISO and then SC, like that, isosceles. What a lovely word to spell. Okay, so there we go. 36. Next question. Question 7. A garden is in the shape of a rectangle A, B, C, D and a semicircle. AD is the diameter of the semicircle. Carol is going to cover the garden with fertiliser. A box of fertiliser costs £4.99. Carol has been told that 1 box of fertiliser will cover 12 metres squared of garden. Work out the cost of buying enough fertiliser to cover the garden completely. Right, so I'm going to write on here, firstly, that the radius of this semicircle is going to be half of 8.4, which is 4.2. Let's first of all do the area of the rectangle. So rectangle is 8.4 times 5.6. 8.4 times 5.6 is 47.04. Okay, that's the area of the rectangle, and that's going to be meters squared. We then need to do the area of the semicircle. Now the area of the semicircle is going to be pi r squared, so pi times 4.2 squared. Now because it's a semicircle is half a circle, we need to half it, so divide it by 2. Alright, divide our answer by 2. So on our calculator, fraction first, pi times by 4.2 squared divided by 2 gives 441 over 50 pi, or if we press S to D, we get 27.7 to 1 decimal place meters squared. Okay, so the total area is going to be 47.04 add 27.7 ... because I've rounded that. I'm going to use the rounded version when I add it, so I've kept this on my calculator. I'm just going to add 47.04. Don't round it beforehand on your calculator, or don't type in the rounded version, because then you end up with a rounding error, or you could do at least. So total area is 74.7 again to 1 decimal place meters squared. So round it when you write it down, but don't round it on your calculator, if that makes sense. Don't type in the rounded version. Total area is this. Now, going back to the question, Carol has been told that 1 box of fertiliser will cover 12 metres squared of garden. So I need to find out how many 12 metres squared will go into 74.7 metres squared. So I'm going to take my answer, 74.7 ... divided by 12. Okay, so this answer divided by 12 gives me 6.23. 6.23, 2 decimal places. So that is how many boxes will be needed to cover the garden completely. If you get 6, it's not going to quite cover the whole garden, so you need 7 boxes. So final bit of working out is going to be 7 times 499. Okay, so 7 times 499 gives 34.93. Okay, now the next part says Carol finds out that 1 box of fertiliser will cover more than 12 metres squared of garden. Now if 1 box will cover more than 12 metres squared of garden, then we're going to be dividing by something that is more than 12. Now if we go back, we can try this and see what happens. So I have to go back a little bit here. So I've got to this point. So that is this bit, 27.7 to 1 decimal place. If I press equals, I get this 27.7, add my 47.04. I'm now at this point. Okay, now if I divide by something which is bigger than 12, so I can cover more garden than 12 metres squared. So divide by, let's go with 15, and let's see what happens. Right, now we get under 5. Essentially the number of boxes we are going to require is lower. Okay, so explain how this might affect the number of boxes she needs to buy. So she may or might need to purchase or buy fewer boxes. Okay, she may need to purchase fewer boxes. Now that's not necessarily true in of itself, because if we go back, I'll just go through this process again. So add 47.04, we get this. Now if we go very slightly lower, so say it covered 11.6 meters squared, so divide by 11.6. Oh sorry, not lower, higher I needed to do, didn't I? So say it covers more than 12, so divide this by, let's go with 12.3. It's still going to need 7 boxes. So just because it covers more doesn't necessarily mean she will need fewer boxes, okay? Because as we've seen, if it goes up by just a little bit, she'll still need 7 boxes. Okay, question 8. Samina has a round pencil case and a square pencil case. There are 4 blue pens and 3 red pens in the round pencil case. There are 3 blue pens and 5 red pens in the square pencil case. Samina takes at random 1 pen out of each pencil case. Complete the probability tree diagram. So we've got round pencil case here. We need to fill in the section for blue and red. So round pencil case, 4 blue pens out of 7. Red pens for the round pencil case is 3 out of 7. For the square pencil case, it's 3 blue pens out of 8. 3 add 5 is 8. And then red pens is going to be 5 out of 8. Your connected branches need to add up to a total of 1, or in this case 8 out of 8, 7 out of 7. And it's going to be the same for these lower branches here, because these are still the square pencil case. So 3 8s, 5 8s. Work out the probability that the pens Samina takes are both red. So we need to go along the red branch and along the red branch. So we're going to do 3 over 7. When you go along the branches, you multiply. Multiplied by 5 over 8. 3 times 5 is 15. 7 times 8, I don't know why I'm doing this in my head, 56. Do it on your calculator. Your calculator will also simplify the fraction, the answer for you. So 3 over 7 times by 5 over 8 equals 15 over 56. So it can't be simplified. Okay. Question 9. Now we've got here 6 graphs, and they're all showing different things, but different equations essentially. So if we go through them, and this is going to be a cubic graph because it's got 3 solutions, and it's going to be x cubed, positive x cubed, because it starts at the bottom, finishes at the top, and goes through my x-axis 3 times. Now cubics don't have to go through your x-axis 3 times, as you see for f, which could also be a cubic. This has got it goes through the x-axis once, okay, but it starts bottom left, finishes top right, but it only goes through once. That's because it's got repeated root. It looks like the root is 0, so that would just be y equals x cubed. Now you don't need to know that, but just the idea that it's only going to have 1 root will help. This is a quadratic. This is an exponential curve. This is a linear curve, so y equals mx plus c, and this is, well, an exponential curve again, but it's getting smaller. Okay, so it's more, it's a different type of curve. In fact, it's not like 2 to the power of x. It's going to be more like, let's say 1 over. So something like 1 over 2. Oh, actually, I mean, yeah, it's difficult to tell because you don't have any numbers on there. But if you have 1 over or a half to the power of something, so as you increase your power, it's going to get smaller and smaller and smaller. So that could be a half there, if you like. Now, obviously, if I do -1, then it's 2. It's going to get higher. So as my x gets lower, -3, not -3, -3 is going to get higher. But as I make it more and more positive, so half cubed is an 1/8. Let's do to the power of 5, 1 over 32, which is lower. It's going to get closer and closer to 0. It's never going to get there, but it's going to get closer and closer. So it's an exponential, but with a fraction, if you like. Okay. Y equals 2 to the power of x. This is an exponential. It's bigger than 1, so it's going to be, what you'd expect to be an exponential will be constantly increasing. So that is going to be D. Part 2, I want to factorise this just to see about any solutions. So if I factorise it, I get x and then x squared minus 3. Okay, so my solutions to this would be x is equal to 0, or x squared minus 3 is equal to 0, which gives me x squared is equal to 3, which gives me x is equal to plus or minus root 3. So I've got three solutions, and it is a cubic, so it's going to have to be this one, okay, A. Now my solutions there are minus root 3, or negative root 3, so here, and then we've got 0, and then you've got positive root 3. Okay, but again, we don't have any real idea of scale because there's no key points on there. Super. Question 10. Now here you've got to multiply your, I won't say number terms, but your constants, your integers out the front. Okay, not your powers. You don't multiply your powers. So 3 times 4 is 12. Then when you multiply, you add your powers. So m, 2 add 3 is 5, so m to the power of 5. And then r, because it doesn't have a power, that means its power is actually 1. So 1 add 6 is 7, so r to the power of 7. Okay, next question, question 11. Tom grows tomatoes. The box plot shows the distribution of the weights of 15 of Tom's tomatoes. Work out the interquartile range. To do that, we need to work out the upper quartile and then subtract the lower quartile. So upper quartile subtract lower quartile, it's the range of your quartiles. Upper quartile is the top end of this box. So if this is 160, that's 170. In the middle is going to be 165, so that is going to be 166. And then each little square is going to represent 1, because there's 10 little squares for 10 units. So 159, 158, this is going to be here, 158. So we've got 166, subtract 158, and I'm going to use my calculator. Why not? I've got it and I don't want to make any silly mistakes. Gives me an interquartile range of 8. Now for the next one, we need to work out the median, then the lower quartile and the upper quartile, excuse me. I'm just making sure I haven't missed any numbers off this page. Now to do that, my suggested way when they've got them listed like this is, unless you've got a really long list, which this isn't, I can just go move my fingers in one at a time. So you've got to move them at the same time. So there, 1, 2, 3, 4, 5, 6, 7, 170. So they both meet on that 170. Now when you've got that, a way to check you've got the median is check you've got the same amount of numbers on either side. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes, so it is in the middle. If they're not equal on either side, then you've gone wrong. Another way of doing it is counting how many numbers you've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 15 numbers. Now this will work no matter the numbers you've got. Now how many numbers you've got? 15 add 1 divided by 2. This gives me the position. So that is 16 divided by 2 equals 8. So the 8th number, 1, 2, 3, 4, 5, 6, 7, 8, that is going to be your median. But you've got to make sure that they're already ordered, they're put in order. Now these are, so it's fine, I can just count 1 to 8 and I can just move my fingers in until they meet in the middle. You can only do that when they're in order, which these already are. Now once you've done that and you found your median, then you essentially need to find the median of each of these sublists. So from 153 to 170, and you can use the same process. So move my fingers in from either side at the same time. Okay, 1, 2, 3, 164. That's my lower quartile, my median, and do the same at this upper end. Okay, move my fingers in at the same time, 175. And again, check these have got the same amount of numbers on each side. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, now from there, what we need to do is we need to plot it in the same way they plotted it up here. And I would try and do it exactly the same. So they've done their lines 2 from the top and 2 from the bottom. So I'm going to do the same. So 170 is my median. So I'm going to go 2 from the top and finish 2 from the bottom. like that. Now I then need to put on my lower quartile, which is 164. So 160, 1, 2, 3, 4. So I'm going to go from here up. And then I need to put on 175, which is nice and easy. It's right in between 170 and 180. Okay, now I also need to put on my lowest point, so 153. That's going to be my left-hand tail. So 150, 1, 2, 3. And then I need to put on my upper limit, or my biggest number rather, 186. So 185, one more is 186. So I'm going up from there to 2 from the top, just so it looks exactly the same. Now the middle 3, they're the ones you're going to join up to make your box. Now I need to join up my whiskers. And there is a box plot to represent that information there. Okay, now compare the distribution of the weights of Tom's tomatoes and the distribution of the weights of Jack's tomatoes. Now this is Jack's and this top one is Tom's. Right, so there's two things we want to think about really, and that's the average, the median, and the spread. So on average, Jack's tomatoes weigh more than Tom's tomatoes. How can I tell? Well, because the median is higher for Jack's tomatoes, as the median for Jack's tomatoes is higher than the median for Tom's tomatoes. Now it's for 2 marks, we need to compare the median, like I say, and the spread of the data. So you could look at your interquartile range, and I would do that because that's what they've done up here. So I will just calculate that, but also you need to relate it to the real world. What does the median being higher actually mean? Well, it means the average is higher. So tomatoes weigh more on average. Okay, now just working out the interquartile range here, we've got 175 as the upper quartile, subtract 164. Okay, 175 subtract 164 gives me an interquartile range of 11. So the weights of Jack's tomatoes are more spread out. The weights of Jack's tomatoes are more spread out, as the interquartile range is 11, whereas Tom's tomatoes interquartile range is 8. I should put grams after this as well, because that's how spread apart they are. They're 8 grams apart, 11 grams apart in terms of the upper quartile and the lower quartile, and that's that sorted then, that's that done, because we've done the median and we've compared the interquartile range and we put it into context about the average weights and more spread out data. Question 12. The diagram shows a piece of wood in the shape of a cuboid. The piece of wood is 3 centimeters by 20 centimeters by 1.2 meters. The mass of the piece of wood is 8 kilograms. The piece of wood will float in seawater if the density of the wood is less than the density of the seawater. In a large pool, 1 litre of seawater has a mass of 1,030 grams. Will the piece of wood float in this pool? You must show how you get your answer. Now, density is mass divided by volume. Okay, I remember it with this triangle. Helps me to remember it. Okay, so you find, to get your density, cover it up, it's your mass divided by your volume. So, what we need to do is we need to work out the density for both of these things, the seawater and this piece of wood. We want to make sure the units are the same for both, so that we can compare the densities. Doesn't really matter which units they are, as long as they're the same. Okay, now, the piece of wood is 3 centimeters by 20 centimeters by 1.2 meters. Let's change this into centimeters. That's going to be 120 centimeters. So we've got, for the volume, 3 times 20 times 120. And on my calculator, 3 times 20 times 120 is going to give me 7,200. Now that's going to be centimeters cubed. Then I've got this in kilograms, so I'm going to change that to 8,000 grams. Okay, now from there I'm going to work out the density by doing mass divided by volume. So 8,000, so this is for piece of wood. Density is going to be mass 8,000 grams divided by 7,200. Gives 1.11 reoccurring. Okay, so 1.1 reoccurring. Now, think about units, that's going to be grams per, so divided by, because that's what we've done, centimetre cube. That means every centimetre cube is going to weigh 1.1 grams. Okay, that's for the piece of wood. Now, seawater. Okay, we've got it in grams. We've got 1 litre of seawater. Now, 1 litre, we're going to have to convert that into centimetres cubed. Okay, now 1 litre is 1,000 centimetres cubed in terms of volume. So again, same process. Density is going to be mass 1,030 grams divided by 1,000, okay, centimetres cubed, and that is going to give an answer of 1.03. Again, grams on the top, so grams divided by centimetres cubed. And so let's read the question again. The piece of wood will float in seawater if the density of the wood is less than the density of the seawater. Now, the density of the piece of wood is not less than the density of the seawater. So I'm going to write 1.1 reoccurring is greater than 1.03. Therefore, the piece of wood will not float in the pool. Okay. Question 13. Now for my year 11 class, this should be, as some students I've heard say, light work. This should be straightforward because we've done this very, very recently. And we may have even done this question at some point. It looks quite familiar. Show that the equation x cubed plus 5x minus 4 equals 0 has a solution between x equals 0 and x equals 1. Now it's a cubic, so like we've seen before, a cubic generally has 3 solutions, could have 2, could have 1, okay, but generally speaking it will have 3. Okay, so it's going to be something like that. Now if it's got a solution between 0 and 1, we could say 1's there, then there will be a change of sign. If I put in 0, I'll get something positive, like there, just above. And if I put in 1, I will get an answer that is negative, it's below the axis. Now because it's a continuous function, i.e. there's no breaks in the line, that must mean that it's gone through my x-axis at some point. It's gone from being positive to negative. Okay, so let's substitute in 0 and 1. 0 cubed plus 5, lots of 0, subtract 4. 0 plus 0 take away 4 is negative 4. And then we've got to substitute in 1. 1 cubed plus 5, lots of 1, take away 4. 1 cubed is 1, plus 5 is 6, take away 4 is 2. Okay. As there is a change of sign between, or for, I'm going to say, for x equals 0 and x equals 1, there must be a solution between 0 and 1. So, just as I had a problem at the start of this video, then midway through, immediately after doing part A to this question, my camera decided to stop recording. So I did the whole rest of the paper without knowing, which is great because that's taken me, I suppose, about another 3/4 of an hour to do, and I'm now going to go through it again for you. So let's do it again. I'll do it again. You'll see it for the first time. Show that this equation can be rearranged to give this. And now looking at the numerator, I want to get the 4 on the other side first of all. So I'll write out my question. I'm going to add 4 to both sides. X cubed plus 5x is equal to 4. And then at the bottom is x squared plus 5. Well, that must have been divided from this left-hand side. Now if I factorise out x, because that's the other part they've got on the top, x is x squared plus 5 is equal to 4. Super. Now I can divide by x squared plus 5. Divide by x squared plus 5. And we get x is equal to 4 over x squared plus 5. Part C. Start with x0 equals 0. Use this iteration formula. xn plus 1 is 4 over xn squared plus 5. And we've got to use it twice. This will find an estimate for the solution of this cubic, and that's one we just rearranged, which is where you get the iteration formula from. So x0 is 0, we're told that. x1 is then going to be 4 over x0 squared plus 5. That's going to be 4 over 0 squared plus 5, which gives us 4/5. x2 is going to be 4 over x1 squared plus 5, which is 4 over x1 is 4/5 squared plus 5. So we're going to plug this into our calculator. I wouldn't expect us to do that in our heads, especially on a calculator paper. 4 over 5 squared plus 5 is equal to 100 over 141. So there are two answers. All we need to do is do it twice. Okay, question 14. The number of fish in a lake decreases by X% each year. Given the number of fish halves in 8 years, work out the value of X. Now, an easy way to do this is to think of a number, an easy number to deal with, like 100. Now, if I was to multiply that by whatever the multiplier would be, 8 times for 8 years, I'm going to end up with half of what I started with. If I started with 100, I'm going to end up with 50. Now, we're just going to work out what this multiplier would be. Now, let's say this percentage was 5%. To work out the multiplier, I do 100, take away, because it's decrease, 5, divide by 100. Okay, that will change it to a decimal. So 100 take away 5 is 95, divide by 100 gives me 0.95, that's my decimal. So I'm going to write that as 100, subtract X, divided by 100. I'm doing that to the power of 8 because that happens for 8 years. It happens 8 times and it's compounded. So what we need to do here is divide both sides by 100. We need to isolate this X. We need to get that as a subject essentially. So we need to undo all of this stuff. First thing to undo is the times by 100. That leaves us with 100 subtract X over 100 to the power of 8 is equal to 50 divided by 100 on our calculators. If you're not sure, is going to be a half. Then we need to do the 8th root. This will undo the power of 8. So 100 minus X over 100 is equal to the 8th root of a half. Now, how do you do that on your calculator? It's actually quite simple. So you need to look for this button here. Now, it's the orange button, so just above X to the power of something. Shift, press that, and it will look like this. Then we need to do 8 here, the 8th root of fraction, 1/2. Press equals, and we get this number here. So that is equal to 0.917004032, and that is 100 minus X over 100. Times both sides by 100 to undo this denominator, and we get 100. Subtract something is going to be equal to 0.917 ... I'm not going to write any more because I only need my answer to one decimal place. So 100 take away something is 0.917. If I add the X to this side, take away my 0.917, times by 100, let me correct myself, I've times this by 100, it's not going to be 0.917 anymore, excuse me, it's going to be 91.7. That's much better now, makes a lot more sense. Times it by 100, 91.7, ... It'd be 004032. So add my X to both sides, that'll move my X over here, get rid of this X, take away 91.7 from both sides is equal to X. That will give you my answer, so I'm going to times this by 100, 91.7, 0040,432. I'm going to do 100, take away that answer, and I get 8.29959568, which to one decimal place is 8.3%. Okay, that's the value of X. So X is equal to 8.3 brackets percent, because it is percent, but X is 8.3. Super. Next question. A and B are mathematically similar, which means there's scale factors between them. There's a scale factor between lengths, there's scale factors between areas, and scale factors between volumes. Now the length scale factor we can work out by doing 10 divided by 8 gives, on our calculator, 5 over 4, or 1.25. So to get from 8 to 10 times by 1.25, that's my length scale factor. Now my area scale factor, in the same way that area the area of this base. Area of the base of pot B is 160 centimeters squared. In the same way that lengths are centimeters and area is centimeters squared, to get from my length scale factor to my area scale factor, I need to square it. I'm going from units to units squared. So 1.25 squared is 1.5625. Okay, I'll just write that down somewhere. 1.25 squared is 1.5625. That's my working out. Now, I need to work out the area of the base of pot A. So I need to go back this way. I'm going from an area to an area, so I need to use my area scale factor. Now, because I'm going from the bigger one to the smaller one, I'm not going to times by my scale factor, I'm going to divide by 1.5625. So 160 divided by 1.5625, that will give me my answer, which is 102.4 centimeters squared. Super. Question 15 done. Question 16. Okay, A is 6.43, correct to 2 decimal places. B is 5.514, correct to 3 decimal places. Now what we need to do here, before even reading the rest of the question, I want to find the lower bound and upper bound for these. So, lower bound of A. Now, the method I would suggest when doing this is to use a kind of number line. So in the middle of your number line, I'll just sketch one. So in about the middle, we're going to put the number 6.43. Now that is correct to 2 decimal places. So go the second decimal place, go 1 down, 6.42, and go second decimal place 1 up, 6.44. Now my lower bound is going to be halfway between the two, 6.425, and the upper bound is going to be halfway between these two, 6.435. So lower bound of A, 6.425. Upper bound of A is 6.435. We're going to do the same with B. So lower bound of B, do our number line. In the middle goes 5.514. Now this is correct to 3 decimal places, so in that third decimal place go down 1. So that's going to be 5.513, and the upper end of this number line is going to be third decimal place up 1, 5.515. Go halfway, 5.5135. and 5.5145. So lower bound of B, 5.5135 here, and upper bound of B is 5.5145. I was just thinking, you have to have a good memory when you're left-handed, because as I was writing that, I had to remember what it was. I can't see the numbers. I can't see what I've written. Okay. Anyway. Now, by considering bounds, work out the value of V to a suitable degree of accuracy. So what we need to do is I need to work out the lower bound of V. Now that is going to be the square root of lower bound of A, it's A on the top, divided by upper bound of B. If you want the lower bound with division, you want the lower bound on top and the upper bound on the bottom. Because if you have a smaller number divided by a bigger number, you're going to get a smaller answer than if you had, say, the upper bound on the top, so a bigger number divided by a smaller number. If you don't believe me, you can try it, okay, and see for yourself. Now, as long as this is above 1, when I square root it, I will get a smaller number. So I do want the smallest answer for this division, as long as it is bigger than 1, which it should be, hopefully. If it's not, then we'll change it and we'll change this around. just to clarify that, if I was to square root something like a quarter, so a number less than 1, it actually gets bigger, so you get a half. Okay. Right, so lower bound of A is square root 6.425 over upper bound of B, which is 5.5145. Yes, because the numerator is bigger, it's going to be bigger than 1. So if we square root it, we are going to get a smaller number, so we'll get the lower bound of V. Type that into our calculator. Square root 6.425 over 5.5145. We get this number. I'm going to write it all out because I don't know what my upper bound is going to be. And however, basically when I round it, whatever number of decimal places, the largest number of decimal places that will round to the same thing, you'll see what I mean in a second, is what would be a suitable degree of accuracy. Okay, so there's the lower bound of V. Upper bound of V is going to be square root of upper bound of A, upper bound on the top this time, and lower bound of B is going to go on the bottom, because it's B on the bottom, but we need the lower bound. Okay, so that's the square root. Upper bound of A is 6.435 divided by lower bound of B, 5.5135. That's going to give us square root fraction 6.435 divided by 5.5135. 1.080340323. Okay, now from there, if I look at these upper bound and lower bound of V, to one decimal place they will both round to 1.1, so that's the same, that's fine. Check two decimal places. Two decimal places will round to 1.08, so they're both the same, so that's good. Try three decimal places. 1.079, 1.080, they're different. So we would want to round or V to a suitable degree of accuracy. So basically, because these have been rounded, if we would use the upper bound or lower bound or any combination, we would always get 1.08 to two decimal places. Okay, so that is the best or the most suitable degree of accuracy. So V is equal to 1.08 to 2 decimal places. And we need to give a reason for your answer. So since both the lower bound and upper bound of V round to 1.08 to 2 decimal places, but are different to 3 decimal places, rounding to 2 decimal places is the most suitable degree of accuracy. Degree of accuracy. Okay, question 16 done. Question 17. Okay, now this looks a bit scary at the start because you've got a sphere and you've got a cylinder, and it's got algebra in there as well. But actually, when you get stuck in, it's not as bad as it looks, as long as you are methodical in your working out. So, as the cylinder has base radius 3x and height h. The metal cylinder is melted, so they melt this down. All the metal is then used to make 270 of these spheres, and each of those spheres has a radius of a half of x. find an expression in its simplest form for h in terms of x. So we need to end up with h equals something x. First of all, let's find the volume of the cylinder. So that is going to be pi r squared times h. So pi times 3x squared times h, which gives us 3 squared is 9, x squared is x squared, times h times pi. Now, volume of sphere, well, that's got to be this volume of the cylinder divided by 270, because it makes 270 spheres. So 9x squared h pi divided by 270. Okay, so that's going to be the volume of the sphere. But also, we've got the volume of a sphere, we've got the radius, so use this volume of a sphere formula up here. 4/3 times pi times by the radius, which is a half of x cubed. Now, let's simplify this down as much as we can. 9 divided by 270, that is 1/30. So on the left hand side we get x squared h pi over 30 is equal to, now we need to do a half cubed. A half to the power of 3 is 1/8. Times that by 4/3. We get 1/6. So 1/6 x cubed as well, x cubed pi. Okay. Now from there, we're going to times both sides by 30. Remember, the question says we need h in terms of x. So we want to have h as the subject. We need h equals. Times both sides by 30, we get x squared h pi is equal to a sixth times 30 is going to give me 5. So that's 5 x cubed pi. Now divide both sides by pi, and we're going to get x squared h is equal to 5x cubed, and again divide both sides by x squared, so that will leave us with h, and we get h is equal to x cubed divided by x squared. When you divide, subtract your powers. 3 take away 2 is 1, x to the power of 1 is just 5x, and there's our answer. H is equal to 5x, and we're done. So a little bit of working out, a bit of a messy algebra, but as long as you follow the correct processes, as you would as if h and x were numbers, then it will work out absolutely fine. Okay, question 18. Now, this is what I would call a standard question, in that I've seen, and I know my students have seen, questions like this several times, quite a few times really, actually. And so as long as you are familiar with the layout of this question, the processes are the same. Obviously different letters, different numbers, but the process is the same. So we need to make m the subject, and m is on the numerator and denominator. So first thing we need to do is times both sides by 5 plus m. This will give us on the left hand side f 5 plus m is equal to, if I times by 5 plus m, my denominator is going to cancel out, so that's equal to 4 subtract 3m. Now my left hand side, f times 5 is 5f plus f times m, which is fm, is equal to 4 subtract 3m. Now I need m as the subject, so I need to get my m terms onto the same side and everything else on the other side. So I'm going to take away 5f, subtract 5f, fm is equal to 4 subtract 3m, subtract 5f, and then I'm going to add 3m to both sides. I'm going to get fm add 3m is equal to 4 subtract 3m, add 3m cancels out, so minus 5f. Then factorise your m out here. That's what we want as the subject. So f plus 3 is equal to 4 subtract 5f. And the last thing we're going to do is divide both sides by f plus 3. And we're going to get m is equal to 4 subtract 5f over f plus 3. So that's our answer. M is equal to 4 subtract 5f over f plus 3. Done. Question 19. Now, having been through this already, and just looking at it, this is going to take a little bit of thought, because what we've got here is a pyramid, and we've got a lot of information on it, really, and in lots of different ways, lots of different shapes, and you've got to think about perspective, which angles are for which shapes, which side of this 3D shape. And it does say, but it's still difficult to see from the diagram. So we've got kind of three shapes here. We've got this triangle on the right, we've got this back triangle, we've got the slanted face, and we've got the bottom of the pyramid. Okay. CD is perpendicular to both CA and CB. We can see that in the right angles. Make sure to read this information, because there might be some information in there that isn't on the diagram. Angle CBD. CBD is 34 degrees. Angle ADB is 45 degrees. Angle DBA is 60 degrees. BC is 20 centimeters. Calculate the size of the angle between the line AD, so this line AD, and the plane ABC. Now a plane is basically a 2D space. Okay, so the plane ABC is talking about this 2D shape, the bottom of the pyramid, the base of the pyramid. So it's the angle between that line and the base of your pyramid. Okay, now basically ADC, if I do a quick sketch, we've got ADC, right angle here. Now that 45 isn't for this triangle. That 45 is for your slanted face. It's the top corner. So I don't actually have any information yet about this triangle. However, I want to look at my right angle triangle. So BDC. BDC is another right angle triangle. So I'll do a sketch of that one and see what information I can put onto this. So BDC, right angle, 34 degrees in there and 20 centimeters along the bottom. Now, using SOHCAHTOA trigonometry, SOHCAHTOA, I can work out DC. Now, DC is a shared side with the triangle that I will need to work out this angle that I want. So, I'm going to use trigonometry. I'm going to do, this is opposite, and this is adjacent. I've got opposite and adjacent, so that's tan. So tan 34 is going to be equal to opposite, so DC, over my adjacent, which is 20. So times both sides by 20. That will cancel out that denominator, and we get 20 times tan 34 is equal to DC. So on our calculator, make sure your calculator is in degrees. It should have that D at the top. If it isn't, your calculator will give you completely the wrong answer. So 20 times tan 34, 13.49017.034. 13.49017.034. I'm writing all the digits because I'm not going to be able to get that back on my calculator without doing this process again, and so it might just be easier to write down all the digits. So DC 13.49017.034. Now all I need to get this angle now is to get another side of the triangle. So I need to get either AD, which is this side, or AC. Now getting AC is going to be difficult because I don't actually know any information about this bottom triangle. But I do know two bits of information about this slanted triangle here, ADB. So let's do a quick sketch of that. So that looks like this, where A is here, B is here, D is here. Now this angle is 60 degrees, this angle is 45 degrees. 180 take away 45 take away 60 will give me the other angle, which is 75. So that angle there is 75 degrees. Okay, right, now that hasn't helped me really yet, but I do need to get AD. If I can get one of these sides, I can use sine rule to get AD. So how can I get one of these sides? Right, now BD. I can get BD by using my BDC triangle again, because I know the opposite now. I know DC. DC is 13.49017.034. Now it's a right angle triangle, so I can use Pythagoras. So 20 squared plus 13.49017.034 squared, and square root it, okay, to get your hypotenuse. That will give you BD, which is square root 20 squared plus 13.49, so on. Make sure you type all your digits in. 017034 squared, 24.12435.897. That is going to give me BD. So then I can put BD on here, this triangle. 24.12435.897. Make sure you can read your own writing. So that should be a 4. Now I need to work out AD. I need to work out this side here. Now I've got a side, I've got an opposite angle. I've got an angle and I've got an opposite side, so I can use the sine rule. So 24.12435.897 divided by sine 75, that's got to be equal to AD over sine 60, the opposite side. So if I times now both sides by sine 60, I'll get AD is equal to this times by sine 60, 24.12435.897 over sine 75 times sine 60. That will give me AD 24.12435.897 divided by sine 75 times by sine 60. Put it where you can see it. So there we go. Times by sine 60 equals 21.629 30853, and we're nearly there now. We're very close because I've got this side here, AD, 21.629 30853. Now what I need to do is use trigonometry again. So I've got the opposite and I've got the hypotenuse. Opposite and hypotenuse is sine. So sine of, it's ADC, isn't it? So DAC, sorry, DAC is equal to opposite over hypotenuse, 13.49017.034 over 21.629 30853. Now to get that angle DAC, I need to do inverse sine. So inverse sine, sine minus 1, 13.49017.034. Now it is a pain having to write down all of these digits, but it's important so you don't get sign errors, because there's no way I can put these exact values in without writing as many digits as come up on my calculator, and that's the best way to avoid getting any rounding errors. Sorry, not sign errors, rounding errors. That has got to be DAC. Okay, so I plug that into my calculator, and whatever I get there is the answer. That's the angle I want. So I'm going to type it in now. Sine minus 1, you have to press shift and then the sine button. That's inverse sine. Fraction 13.49017,034. On the bottom, 21.629,308.53. Press right, close bracket, equals, and we get to 1 decimal place, 38.6. To 1 decimal place. Okay. And that's it, done. One of the most difficult questions on the paper, definitely. Takes a lot of, well, takes a good amount of thinking and a few diagrams to help think about what you've got to do there. But if you see right angle triangles, think Pythagoras, think trigonometry. And then if you've got triangles that don't have a right angle in it, think sine rule, think cosine rule. Okay, next question. Nearly finished. Question 20. Find g of negative 4. So in our g function here, we're going to replace x with negative 4. So g of negative 4 is negative 4 in brackets squared plus 2. If you don't put the negative 4 in brackets, it will square the 4, 16, and then make your answer negative, which isn't what you want. Okay, negative 4 squared is 16, add 2 is 18. G of f of x. So it will help with these questions if you put brackets around that f of x. So what we're going to do is we're going to take f of x and we're going to replace the x in g of x with f of x. So we're going to replace all the x's here, just the x squared, with 2x minus 3 squared. So this is going to be g of f of x is equal to 2x minus 3 squared, so we've replaced the x with 2x minus 3 plus 2. So you take your f of x and you put it into g of x. So you replace every x with whatever f of x is. That's 2x minus 3 times by 2x minus 3 plus 2. Again, eyebrows, mouth, nose. 2x times 2x is 4x squared. Negative 3 times by negative 3 is going to give me positive 9. I'm just going to write that over here because I know I'm going to have x terms in there. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. And then we've got the plus 9. Don't forget this bit at the end, plus 2. Make sure you bring that down. Plus 2. Simplifying that, we get 4x squared. Negative 6 is negative 12x. 9 add 2 is 11. There we go. Now, f of g of x is equal to g of f of x. We've already got g of f of x. That is 4x squared minus 12x plus 11. So we need to work out g of f of x. So take my g function and replace x in f of x with my g function. So it's going to be f of g of x is 2 lots of x squared plus 2 minus 3. So that's going to be 2x squared plus 4 minus 3, which is 2x squared plus 1. 4 take away 3 is 1. So we've got 2x squared plus 1 is equal to g of f of x, which is here, 4x squared minus 12x plus 11. Now we need to get a quadratic equal to 0 before we can solve it. So what I want to do is take away 2x squared. I'll get this left hand side equal to 0, and once I've taken away the 1 obviously as well. Take away 2x squared from both sides. We end up with 1 is equal to 2x squared minus 12x plus 11, and then take away the 1 from both sides. 0 is equal to 2x squared, subtract 12x plus 10. Now at this point we've got our calculator, so just use the quadratic formula. Quadratic formula is minus b plus minus the square root of b squared minus 4ac all over 2a. Now the square root goes all over that b squared minus 4ac. Now what does that mean? How do we type that into our calculator? Well, a is whatever's in front of the x squared, b is whatever's in front of your x, and c is the constant term at the end. So in our case c is plus 10. B is negative 12, and A is 2. So we're going to have negative B, which is negative 12. Put your negatives in brackets. Square root, plus or minus the square root of B squared, so negative 12 squared, subtract 4 times A, which is 2, times by C, which is 10. All divided by 2A, which A is 2, so 2 times 2. Now that will give us the solutions. So we're going to go straight to our answer now, once we type this in. Fraction button first. Negative, brackets, negative 12, plus square root of brackets, negative 12 squared, subtract 4 times 2 times 10, down 2 times 2. So x is 5, or x is equal to, now go and change this plus to a minus 1. X is 5 or x is 1. And that's it for question 20. Final question then, 21. Now, for those of us at the school I teach at in year 11, we haven't done circle theorems yet. So this question will be, unless you've done circle theorems elsewhere, essentially very, very difficult, near impossible. All right, pretty much it will be impossible if you haven't seen circle theorems before. What we need to do is we need to prove that the sum of angle ABC and angle ADC is 180. So sum obviously means we add them together. So this angle add this angle is 180. Now what we're proving actually is one of the circle theorems. One of the circle theorems is that opposite angles of a cyclic quadrilateral add up to 180. Now a cyclic quadrilateral is basically a quadrilateral where all of the vertices lie on the circumference of a circle. Now opposite angles will add up to 180, so the angle at B and the angle at D will add up to 180, and the angle at A and the angle at C add up to 180. Now with this question we need to prove that, so we can't use that, we can't assume that, we have to prove it. So it doesn't say we can't use any other circle theorems, so we can do, and we will use those. Now if I draw a line from A to the centre of this circle, it says in the question that the centre of the circle is O, and then from O to C. If I say that this angle here is going to be Y, and the angle on the other side is going to be X. Okay, so we are going to, you can label it, but it's also good to reference it. So I'm going to write something down. So let angle AOC, now I've got to be specific here because AOC could be either side, in shape BAOC BY. Then I'm going to say the same thing for X. So let angle AOC in shape, this time the other side, so AOCD or DAOC BX. X plus Y is equal to 360 degrees because angles around the point add up to 360 degrees. Now, angle ABC, so ABC, this angle here, must be a half of X, as the angle at the circumference, so if we forget about these two lines here, okay, we've got what is kind of like an inverted arrowhead, and it's more obvious if you kind of forget about these two lines initially. So this here is an arrowhead, okay, so the angle Y there is going to be double the angle on the circumference. So this angle here at D is going to be half Y, and vice versa. If I get rid of these lines here, and the angle at the base of my arrowhead, X, is going to be double the angle at the circumference. Okay, now it's a bit more confusing because it's 2 in 1. but that's essentially the rule we're using. So angle ABC must be half x as the angle at the circumference so the angle at the circumference is half the angle at the center. So the same thing now for angle ADC. So angle ADC must be a half y as the angle at the circumference is half the angle at the center. And then if we do the sum of those angles, so angle ABC plus angle ADC, that is a half x plus a half y. Now we can factorise out the half, so we get half x plus y. Now we know that x plus y is 360, since x plus y is 360 that we mentioned earlier, 360 degrees. And a half of 360 is 180 degrees. Okay, and then you can do your square or write proven, because we finished our proof. Okay, now that was a definitely an involved paper. There were a few questions on there which were quite challenging. So, you know, the last one we just done there, 21 and question 19 were quite involved and challenging. So by no means was it an easy paper, especially those last questions. So, you know, just bear that in mind, obviously, when you go through it and when you're marking it. And especially this question, like I say, we haven't seen this yet in Key Stage 4 if you're from the school that I'm at. So it's going to be very, very difficult if you haven't seen any circle theorems since probably year 9 to be able to do that, and you've never seen a proof one like that. Okay, right, well, that's the end of the assessment, people. If this was of any use at all, please like it. The feedback is important, you know, to me, and also so that I keep making the videos. I know that it's useful for you, and if it is, of course, you know, well, I'm going to keep making them anyway, but it's always good to get feedback, because then I can always make other videos on other topics in the future as well. So yeah, please like and also subscribe if you want to make sure you don't miss, or well, you make sure you don't want to miss the next videos. I'll be making a new video on another test every 2 weeks. So in 2 weeks' time, I will have another test with work solutions up. Okay, thank you everybody. Bye-bye.